Good morning, ladies and gentlemen. My name is Hamideh. I am project manager and R&D engineer at Valunor, which is the name of our startup company. And my background is material science and engineering. Today, I'm going to present the unique properties of Minolite, which is a lightweight aggregate. We are actually not expert in concrete and GFRC, but we are quite confident about the properties of our product and how it will help to improve the performances of GFRC. So I will present first who we are and then what is Minolite. I will talk about the production process and properties of Minolite and also the applications. And then I will show you some of the results of the test we have done on concrete, mortar, and GFRC when Minolite was incorporated in them. I would like to mention that we have been selected as one of the top 50 Contech startups in 2021. Where we were nominated in a group of 14 in green building category. So this is the history of Valunor. And as you can see here, in 2017 and in 2018, we did multiple years of research, and the main goal was how we can valorize the glass waste. So we did different, we had different options, but in 2019, we have found that one of our options, which is producing lightweight aggregate from glass waste, showed very good results. So we continued with that, and then we started the patent development, and in 2020, we filed a patent, and we started the pilot. We are based in Norway, close to Oslo. And then in 2021, we developed the quality control of the product, and also we started to develop our partnership with different engineering companies and with different research institute and external labs. And now in 2023, we are doing optimization and also some broader qualification control, and we are almost in technology readiness level 8. So we are planning to start our commercial production in 2024. So this is an overview of what we are doing. We are using glass waste, which contributes to land toxicity, freshwater toxicity, and ocean acidification, to a very valuable lightweight aggregate, very valuable product in construction industry, through a patented technology, which is non-CO2 emitting process. What we are doing is that we are milling the glass waste to powder, and we are adding some additives, and then we are doing the sintering process, and after that crushing and coating, and then expansion or foaming in a fluidized bed. And you can see a picture of our expansion kiln in the back. And then we will have screening of the final product and packaging. And you can see the final product here. This is the flow chart of our process. As I mentioned, we have the glass powder preparation, and after that, high temperature sintering. And then we crush the sintered material and screening. There is an innovation step here where we screen the material, the particles before expansion, which means we have full control over the size of the product. After that, we have this patented step, which is two-stage dry coating. This is completely dry coating, no water, no binder, no adhesive. And then after that, we start with expansion process. This expansion process is also patented. And then after that, we are screening the final product. So now we are comfortable with producing 4 different fraction sizes: 0.5 to 1 millimeter, 1 to 2, 2 to 4, and 4 to 8 millimeter. But we are also working on optimizing the parameters for production of particles less than 0.5 millimeter, and also larger particles larger than 16 to 30 millimeter. So here I'm explaining the expansion mechanism. So you see that we have a particle here, which includes glass particles and also some additives, and a foaming agent, expansion agent. At higher temperature, around 200 and 600, we have the shrinkage of this particle because the moisture is evaporizing. And then after that, at higher temperature, 600 to 900 degrees C, the glass particles start to soften. And also the foaming agents start to decompose. So this is the oxide reduction, and gas is generating from these chemical reactions, and this gas forming pores inside the particle, which you can see the final product, which is expanded particles here. If you look at the density, the starting density is 2,300 kilogram per cubic meter, while the end product density is less than 350 kilogram per cubic meter. Our technology and our product is aligned with at least 5 of UN goals. We are using glass waste and also 100% mineral based. There is no polymeric additives, and also this is completely CO2 free process, because the high temperature furnaces that we are using, they're using with electricity. And also it's renewable energy. So this low density allow us to use this product somewhere that anti-fire protection is needed and isolation properties is needed. So if you're wondering how does Minolite look like, this is the particles of around 4 millimeter that I have cut them in 2 so you can see inside the particle. So I believe that all of us agree that the size of particles and shape of particles is influencing the interlocking of particles and the packing of the concrete matrix. So Minolite is rounded or potato shaped, as you can see here. If you look at the microscale, you can see that there are some small pores on the surface, and also you can see that the rough surface texture. So there are some small pores on the surface, while if you look at the cross section, you can see larger pores inside. These pores are mostly closed and separated. The texture of the aggregates influencing the adhesion between aggregates and cementitious material. So the rough texture shows better adhesion properties. You can see that these small pores on the surface have another advantage. The hydration product and the cementitious material can penetrate into these small pores and act as multiple hooks, binding aggregates and cement paste phase. These are some key properties of Minolite. So if you look at the bulk density of different fraction size, you can see that, for example, for 0.5 to 1, the bulk density is 320 kilogram per cubic meter, and as the particles are getting larger, the density is decreasing. And if you look at the crushing resistance, it is a very interesting result here, because we expect that when the size of particles are increasing, the crushing resistance is decreasing, but it's opposite in Minolite, because we believe that this is because of the special formulation of the coating of particles. And the other thing is the water absorption. Water absorption is very low. This is unexpected in porous structure, because porous structure is responsible for the high water absorption. And high water absorption is not desirable for a superior quality concrete. But Minolite has a special coating that not only seals the pores on the surface, but also keeps the low density. And I'm sure that you're wondering, because we are using glass waste, maybe you're worried about the ASR, but we have tested that. And because of some additives that we are adding to the mixture at the beginning, we haven't observed ASR. This is the crushing resistance versus bulk density, a comparison between Minolite and two different product offers in the market. So you can see expanded clay here. So Minolite has lower density and higher strength, higher compressive strength. And if you compare with another type of expanded glass, you can see that Minolite has higher strength. Low density of Minolite allows to design lightweight concrete with low desired density. And the other thing is that because Minolite has low density, the thermal conductivity is very low, because you know that density has exponential relationship with thermal conductivity. So these are some applications of Minolite, concrete, precast and ready mix, and also dry mix mortars and plasters, and also some special applications. For example, in marine and offshore concrete, anti-ballistic concrete, anti-seismic system, anti-fire production, and last but not least in GFRC. Here are some of the results that I would like to show you. The compressive strength versus curing days. So Minolite was used in concrete, and gravel in concrete was replaced by Minolite partially. And you can see the green columns are Minolite, and the gray one is the reference without Minolite, the normal one. So you can see that, as we expected, the compressive strength is a bit lower, not very significant. For example, you can see after 28 days of curing, we have 36.7 megapascal, while the normal one has 44.3 megapascal. But if you look at the density, you can see that the density of Minolite is significantly lower. And if you look at the thermal conductivity, you can see that thermal conductivity for Minolite is 0.75, while for the normal concrete is 1.46. And we have also results for mortar when Minolite is incorporated in it. So sand was replaced by Minolite partially, and also we compared it with a competitor. The replacement was exactly the same. And you can see that compared to our competitor, the compressive strength of the mortar is higher. And if you look at the density and thermal conductivity, you can see that they are very similar. We have also tested Minolite in GFRC. So we have replaced sand in GFRC with Minolite. We have two different formulations. R16, 100% Minolite, no sand. R17, 50% Minolite and 50% sand. So you can see the boards of 600, 612 millimeter with 50% sand and 50% Minolite. And the other ingredients is the same. So we have done the bending test machine, or external labs did that, and we have done 4 different tests for one sample. And you can see the R16 stress strain curve here, following the standard EN 1170. And this is for R17, which 50% Minolite was used. And you can see the higher MOR and LOP. And this is the comparison between them. So the last one is the typical GRC mix. And this one is when 50% Minolite was used. So you see that, of course, the flexural strength is a bit lower, but when you're using R16, the flexural strength is even lower, but we should consider that the density of this one, R17, is 4 times less than the density of the typical GRC mix, which is very significant. But the compressive strength is lower, but not very significant. We have also done some tests on thermal conductivity. So we have produced 2 panel boards, or external lab has done it, 2 panel boards with partial replacement of Minolite. And then following standard EN 12664 and the guarded hot plate test. You see, these 2 are when we have used Minolite and with different particle sizes. And the thermal conductivity is very low. If you compare with the conventional concrete, which the thermal conductivity is 1.6. So thermal conductivity has a significant difference. I don't have the information for the typical GFRC mix, but I guess I saw in the literature that it's like the density and the thermal conductivity is even higher than the conventional concrete. So density for these 2 that Minolite was used is around 800 kilogram per cubic meter. I also have this block that we have used Minolite in, and we have measured the thermal conductivity. We have put this in the stand for thermal spray. What? Sorry, power spray. I forgot the name. Power spray. And if you would like to look at it, you can just, Yes, to wrap up, Minolite is produced through an innovative and CO2-free process by using recycled raw materials and minerals. The rough surface texture of Minolite shows better adhesion properties with cementitious material and facilitate good rheology behavior. The incorporation of Minolite with concrete and mortar resulted in a significant reduction in density while achieving high compressive strength. and the incorporation of Minolite with GFRC improved its isolation properties and brings acceptable flexural strength while lowering the density. And Minolite allows high-performing green, low-density construction material. Thank you for your attention.